Good afternoon, everyone. Myself, Dr. Sugandha Agarwal from the Department of Public Health Dentistry. We're going to take a lecture on water pollution. Introduction. Comprising over 70% of Earth's crust, water is undoubtedly the most precious natural resource that exists on our planet. Without the seemingly invaluable compound comprising hydrogen and oxygen, life on the Earth would be non-existent. It is essential for everything on our planet to grow and prosper. Although we are humans recognize this fact, we disregard it by polluting our rivers, lakes, and oceans. Subsequently, we are slowly but surely harming our planet to the point where organisms are dying at a very alarming rate. Pure, uncontaminated water does not occur in nature and contains impurities which are natural, man-made miscellaneous. Sources of water pollution, industrial waste. In this, various chemical waste produced as a result of manufacturing process, domestic waste like waste food, toilet and sewage, kitchen or sewage water, solid waste such as plastic, paper, etc. Agriculture waste like pesticides, residues, fertilizers, animal excreta, hazardous hospital waste, needles and syringes used, gloves, blood and organic materials, plastic intravenous tubes, etc. Hotel waste, leftover food, utensils, cleaning water, etc. Urban waste, discarded building materials. All the above waste pollutes our atmosphere chemically, physically, and biologically. Waterborne disease. Man health is affected by the ingestion of contaminated water either directly or through food and by the use of contaminated water for the purpose of personal hygiene and recreation. Hence, water-related disease may be classified as chemical waterborne disease and biological waterborne disease. Chemical waterborne disease derived from industrial and agriculture waste include detergents, solvents, cyanides, heavy metals, minerals, and organic acids. Nitrogenous substances, bleaching agents, dyes, pigments, sulfides, ammonia, toxic, and biocidal organic compounds. The effect of these substances may be direct on the human health, affect indirectly by accumulating in the aquatic life, which is used as a human food. Biological waterborne disease, those caused by the presence of ineffective agents like viral, bacterial, protozoal, helminthic, and leptospiral. Water purification method. Water purification would be an important component of community healthcare. It must be emphasized that the quantity of water available is as important as the quality of water. Large quantity of water availability leads to an easier adoption of the cleanliness behavior other than an only higher quality of life. There are various methods of water purification. First is home-based methods, boiling for 20 minutes or till roll boiling. This is the ideal method which also kills spores, but it requires easy and cheap availability of fuel, time, extra vessel, etc. Chlorination of water using chlorine tablets. Filtration using special various types of membranes. This only prevents bacterial contamination like viral, diarrhea, hepatitis, polio, etc. Defluoridation method for removing excess fluorine which causes dental fluorosis by the Nalgonda technique using dried and burnt paddy husk. Sedimentation by storing water which results in bacteria etc. settling to the bottom of the vessel. Use of alum crystals leads to coagulation, clumping of bacteria and settling to the bottom of the vessel. Clean water should be stored in the closed vessel with cheap plastic taps for taking out water out by slow decantation, tilting the vessel to pour out care required amount instead of dipping in the glass to fill water. Community-based method, chlorinated drinking water wells using bleaching powder to achieve a minimum of 2 parts of chlorine per million parts of water. Using sand filter fluoride by large-scale chlorination and providing the water through community-based centralized large closed water tanks fitted with the multiple taps. Using deep bore wells fitted with hand pumps. Maintaining a separate drinking water well. These drinking water wells must have a cover fitted with hand pumps and used only for collecting drinking water. The well must be dug deep enough to cross the first impervious layer of the soil deep in the ground. This is to prevent surface contamination from seeping or sinking into the bottom of the well. Water treatment method. Screening. A municipal surface water treatment plant must first screen or sieve out large objects such as trash and leaves. The tighter the mesh of the sieve, the smaller the particles must be passed through. Filtering is not sufficient to completely purify water, but it is often a necessary first step since such particles can interfere with the more thorough purification method. Storage water from rivers may also be stored in the bankside reservoir for a period between a few days and many months to allow natural biological purification to take place. By mere storage, the quality of water improves and about 90% of the suspended impurities settle down in 24 hours by gravity and water. Certain chemical changes also take place during storage. From the biological point of view, a significant drop takes place in the bacterial count during storage, and as much as 90% of bacterial count drop is first 5 to 7 days. Filtration, this is the second stage in purification of water, and it is important stage because 96.99% of bacteria removed by the filtration. These are of two types. First is biological, that is slow sand filter, mechanical, that is rapid sand filter. Slow sand filters is elements which are used in these are raw water, graded sand bed under drainage system. Where sand and space are available, water may be treated in slow sand filter beds. Is fairly and biological treatment process for this action other than the physical filtration. Slow and sand filters are the carefully constructed using graded layers of sand with the chorus of the base and fineness at the top. When a new slow sand filter is brought into use, raw water is carefully decanted into the filter material until the water depth 1 to 3 m is achieved. It depends on the size of the filter bed. The water passing through the filter for the first few hours is recirculated through the filter and not put into a supply. Within a few hours, a biological film comprising of bacteria, protozoa, fungi, and algae builds on the surface of the sand, and this is called the Sugandha layer, and it is this layer that removes all the impurities. This is also called the vital layer, Zuglil, or the biological layer. This layer is slimy and gelatinous and consists of thread-like algae and numerous bacteria. Vital layer is a heart of slow sand filter and removes organic matters, filters bacteria and oxidizes ammoniacal nitrogen into nitrates and helps the yielding bacteria. Free bacteria. Advantages: it is simple to construct and operate. The physical, chemical, and biological quality of filter water is very good. It is cheaper. Slow sand filter has been effective to reduce total bacterial count by 99.99%. Rapid sand filter, these are of two types: gravity type known as Patterson filter, pressure type known as Candy filter. In this, a coagulation is done. In this, the raw water is first treated with the chemical agent coagulants such as alum from 5 to 40 mg per liter. Rapid mixing, the treated water is then subjected to the vigorous agitation in the mixing chamber for few minutes. This allows dissemination of the alum and water. Flocculation, this involves the slow and gentle stirring of such treated water in a flocculated chamber for a period of 30 minutes. The most commonly used flocculator is mechanical type. Next is sedimentation. The coagulate water is allowed into sedimentation tank and it is detained for 2 to 6 hours, allowing for impurities and bacteria along with the flocculant precipitate to settle down in this tank. At least 94% of the flocculant precipitate needs to be removed before water is admitted into the rapid sand filter. Filter bed. Each filter bed has surface of 900 to 100 square meter feet sand in the filter media. The depth of the sand bed is usually about 1 meter, and below the bed layer the graded level between the 30 to 40 centimeter. The depth of the water on the top of the sand bed is about 1 to 1.5 m. The rate of filtration is about 6 to 16 cubic meter per square meter per hour. Filtration, the alum floc which is not removed from sedimentation is held back on the sand. This forms a slimy layer. Compare a jugular layer is called the slow sand filter. It absorbs bacteria and water. Rapid sand filter requires frequent washing either daily or weekly depending on the loss of the hand. Washing is accomplished by the reversing the flow of the water through a sand bed which is called the backwashing. Advantages: the space required for sand filter is less. Filtration is quite rapid. Washing and cleaning of the filters. Disinfection, this is another method. And there's a finished water is infected with the chlorine gas, chloramine, perchlorine, chlorine dioxide, ozone, and ultraviolet. A chemical agent to be potentially used for disinfectants has to satisfy the following criteria. It should be capable of destroying the pathogenic organisms. It should not leave products of reactions which might make water toxic. It should be dependable and readily available at the reasonable cost. Chlorination. Chlorination is one of the best advances in purification of water. It is developed supplement and not a substitute to sand filtration. This is the action. When the chlorine is added to water, there is a formation of hydrochloric acid and hypochlorous acid. The hypochlorous acid ionizes to form hydrogen ions and hydrochloric ion. The disinfecting action of the chlorine is mainly due to hypochlorous acid. Methods are chlorine gas, chloramine, perchlorate. Other water purification techniques are carbon fitting, distilling, reverse osmosis. This is a mechanical pressure is applied to an impure solution to the forced pure water through a semi-permeable membrane. Potable water purification. The potable drinking water system or chemical additives are available for hiking, camping, traveling in remote areas. By this, the 5,000 to 50,000 liters per cartridge water can be filtered. Next is solar disinfection. Thank you. This is all about the water fluoridation.